Why do we die? We die because of the buildup of error. Error in our DNA, errors in our cells because of chaos, the second law of thermodynamics. Things rust, things fall apart, things die. But if you add energy from the outside, you can get around the second law of thermodynamics. For example, with gene therapy, we'll be able to attack aging at 3 levels. One is telomerase. We know that a cell has a clock. A clock, skin cells divide 60 times and then they go into senescence and then they die. Why? The telomeres get shorter and shorter and shorter. It's like a clock. After 60 reproductions, the cell dies. However, we've now discovered telomerase. A Nobel Prize was given for the discovery of telomerase. It stops the clock. Now, why don't we all take telomerase? Got to be careful. This is powerful stuff. You see, telomerase also is used by cancer cells. Cancer cells are also immortal. That's why they kill you, because they are immortal. And that's one way that cancer cells become immortal. So we have to control telomerase. Second, we know that if you want to live 30% longer, eat 30% less. This has been checked on spiders, insects, mammals, all the way up to primates. You feed them 30% less, they live 30% longer. Why is that? Because you slow down the oxidation process. And Mother Nature knows that in case of a famine, animals face famine all the time. Animals have a choice. They can either reproduce or they can gut it out and go to senescence, hibernate, whatever, and then when there's food, flourish once again. So we now have isolated the genes that control this process of gutting it out during times of famine, which of course is very common for animals. And many people are looking at these enzymes which slow down metabolism because we want to live forever without having to live like a monk. We don't want to eat 30% less. We want to eat lots of food and still live longer. And that gets us into oxidation. Why do cars get old? What ages in a car? Well, it's the engine. Why the engine? Because that's where you have combustion, oxidation, wear and tear. Well, where is the engine of a cell? The mitochondria. Bingo. We now know where errors build up in a cell, the mitochondria. And with gene therapy, with CRISPR technology, one day, I think that maybe our grandkids will hit the age of 30 and stop. They may like being 30 for many decades to come. I think that's well within the realm of possibility, given the rapidity with which we are now unraveling the question, why do we have to die? Now, look at it this way. Look at the Greenland shark. The Greenland shark lives to be about 500 years of age. We know that because just like tree rings, you can look at the eyeball of the fish, count the rings, and calculate the age of these fish, and they are between 400 to 500 years of age. So in other words, why do we have to die? In the Arctic, where these fish are, metabolism is much slower. And slower metabolism means errors build up slower. And again, that's what aging is, the buildup of genetic and cellular mistakes. They build up, cells get sluggish, they eventually die as a consequence. But with gene therapy, perhaps we can reverse that aging process, correct the mistakes. So this is something that we should think about. It's not for us, we're not there yet, but we have tantalizing clues as to the mechanism of how aging takes place. In cells, in worms, for example, we can actually double their lifespan. And as I mentioned, you can take any animal up to humans and make them live 30% longer. The second law of thermodynamics says that in a closed system, things decay, things get older, things fall apart, things die. The key word is closed. In a closed system, things naturally get older. In an open system, like you have sunlight, energy from the sun, that can reverse the process. That's how evolution takes place. Evolution should violate the second law of thermodynamics. People get, if you take a look at human evolution, we got smarter, we got more adapted to the environment. Why? Because we had extra energy from the outside. sunlight. Now that open system could be biochemistry. And so biochemistry could replace sunlight and speed up this process. Instead of waiting millions of years for evolution to catch up, we may be able to do it in one generation.